today's webinar, Lean Project Management. This is part 2 of a 2-part series on lean project management. Part 1 focused on eliminating waste, how to get rid of waste in our processes. Part 2 is how to improve workflow. This series takes general lean principles, which are an operations management discipline, and extracts from them components that can work in a project management context and applies them there. I'm Kevin Aguanno. I'll be your instructor. Welcome to today's session. Okay, so let's go into this a little bit. First of all, a little bit about myself. I've been a project manager now for, just over 30 years. I've written over 30 books on project management and agile and lean related topics. I've got tons of experience across multiple industries and lots of certifications and fellowships on project management and lean and agile project management. And in all the years I've been doing this, I've really understood how we can improve efficiency on our projects by getting this workflow process resolved. Okay, so let's talk about our agenda for today. We're going to recap a little bit about waste reduction. Part 1 talked extensively about eliminating waste. We're going to touch on that a little bit just to recap some of the key points in case you missed that first webinar. Secondly, we're going to be talking about one of the lean workflow tracking and visualization tools called Kanban. We'll talk about Kanban. Then I'm going to talk about line balancing, process mapping, DFMA, and DFEU. So we'll talk about those two options as well. And then another concept called one-piece flow. Sometimes they talk about push versus pull. This is one-piece flow. We'll be talking about that lastly on our agenda today. So we're taking some of these lean concepts and applying them to the project management context. So first, let's just recap some of our discussion around eliminating waste. In our first session, we discussed the 8 types of waste. 8 types of waste. So there's one which is called muda, which is waste, and there's another one called muri. These are Japanese terms. So there's all kinds of things that can cause waste in our projects. There is inefficiencies in how we store and move materials. There's inefficiencies in process itself, duplication and wasted efforts. There's errors as a source of waste. So we talked about the 8 different types of waste. We talked about the 5 elements of lean. So having a value focus, focusing on value, delivering value, keeping value, customer value, business value is our main focus. Something called value stream mapping, which helps us figure out where in what steps is value being created and which steps are open to more optimization because they're not adding value that might be worth it for all the process that they're going through. We talked about the need to improve flow through the project, to improve throughput and flow, to reduce waste caused by inventory or work in progress and errors and things like that. Talked about using a pull approach and the idea of looking for perfection and how that can be very elusive and expensive and wasteful as well. We talked about the 4 rules of lean. Work standardization is absolutely important to improve consistency and predictability. We talked about limiting material movement and people movement and the need for education. And lastly, we look about one technique to identify and eliminate waste, which is Kaizen. Kaizen is a continuous improvement activity that is collaborative, involves multiple people on the team with a focus on identifying and finding causes of variance and waste and getting rid of them quickly. Okay, so let's get into our new content. Let's talk about Kanban. Kanban started with Toyota, the car company. Toyota has something called the Toyota Production System. And inside the Toyota Production System, there is a tremendous focus on improving the workflow, the flow of work through their production process. Imagine a manufacturing factory, and above each workstation in the factory where we're building and assembling the cars, imagine above each workstation there's a pole with a stoplight on it, red, green, or yellow. And the workers have buttons they can push to change the status of those lights. If everything's going well, all the green lights are on throughout the process. Everything's running smoothly, the green lights are on, everybody's happy. Now, there's foremen standing up on platforms in the factory looking out over the sea of lights, looking for changes in light color. And if somebody slows down, they press the yellow button. The yellow button will slow things down and indicate that they might be having a problem. The foreman gets on the walkie-talkie and yells, "Yoshi, go run to workstation 22, they got a yellow light." And the person will run over and say, "Okay, what's going on? Why is there a yellow light?" Now, something might be slowing down that workstation, and we need to nip that in the bud right away, because those kinds of delays become infectious. Because if workstation 6 is slowed down, next will be workstation 7 will be slowing down because there's delays in the output from workstation 6. And then workstation 8 will be slowed down because that problem, that delay, tends to cascade down the line. Eventually, the whole line past that workstation slows down, and all the yellow lights will propagate past that point. And also the lights before that workstation will start to light up as well, because nobody wants piling up work in progress in complete inventory. If workstation 6 isn't using up materials fast enough, workstation 5 that's providing those materials will have to slow down, because they don't want a pile up of incomplete stuff showing up there. So they'll slow down, and the yellow lights will continue upstream as well. So a yellow light is infectious. It will propagate first downstream and then very quickly upstream, and it becomes an issue. So the foreman will send somebody to that workstation right away with the yellow light and say, "What's going on? We got to fix this fast." Now, it might be a temporary cause, right? The workstation might be slowing down because maybe somebody says, "I dropped all my tools, and by the time I picked them up, I got a little bit behind." So Yoshi might stay in that workstation and help that person get caught up again. He'll call the foreman on the walkie-talkie and say, "It's a temporary issue. I'm just going to help him out for a bit. Once he's caught back up, I'll go back into the pool. I'll let you know." And pretty soon, Yoshi helps the person get caught up, and that yellow light turns green, and everybody breathes a sigh of relief, right? Everything's running smoothly again. Or it might be something more persistent, right? It might not be that the person dropped the tools. It might be that the manufacturer shipped all the car seats that the person was putting in the car, but now they all came suddenly pre-wrapped in plastic. They never used to be, but now they're all wrapped in plastic, and the person has an extra step to unwrap them all. So Yoshi will explain the problem to the foreman and say, "I will stay here for the rest of the shift, helping this person unwrap the seats," right? So that we can get caught up onto our normal flow. Meanwhile, you go yell at the manufacturer and tell them the next shipment of seats better not come pre-wrapped like that. It's slowing us down. Fine. So the person helps with the pre-wrapping. Pretty soon they get back up to speed, and the light goes green again. Everything's fine. Right? So these lights indicate potential problems right away. They indicate bottlenecks in the production workflow, so we can assign more resources to help with those problems and get them adjusted quickly. Another issue might be a dead stop. Somebody hit the red button, which stopped the line. They could actually stop the production line by hitting that red button. Red button is, the red light turns red, alarm goes off, people get all panicked. "Oh my God, it's a red button, the line is stopped. We could be losing incredible amounts of money every minute that this line is down. Let's go figure out what the problem is." The poor foreman has a heart attack. "Yoshi, get over there." The person runs to the workstation. "Okay, what's happening?" Now, it could be something temporary, right? One of the people who's providing me seats is ill. He fell down, he's ill, he's collapsed, he's having a medical issue. So can we call an ambulance, get the person out of here? We'll bring in another worker to replace him. As soon as the other worker's there and available, we can start the line back up again. The yellow light goes away and everybody gets back to work. But the red light is a signifying a significant problem. We have to stop the line, because you do not want a car going down the line with no seats in it because the seat guy, had a heart attack or fainted or something. You don't want that car going down the line with no seats in it. Now, obviously, seats pretty obvious. We would pick that up in a QA step later on. But something a little bit more tricky might be a problem, like the brake lines never got installed properly or weren't completely hooked up. You don't want that, or the nuts weren't tightened all the way on the brake lines. That could be a problem, causing a leak, and maybe then somebody gets hurt in a car accident when they suddenly slam on their brakes and they fail, right? So we don't want to have problems in the system. So as soon as we spot a potential source of a problem, we stop right away, fix the problem so we don't bake problems into the product in the first place. That's the essence, the point of the Kanban model. Now, Kanban is the Japanese word for billboard or signpost, right? Kanban, ban means sign, right? And kan would be the billboard sign or the, right, something like that. So the idea is that Kanban is a way of visualizing the flow of work, and these signs or these lights are notifying us that there's a problem and we can take immediate action. So we can watch the flow and how smoothly things are flowing. If there's a bottleneck, we see it right away. We can assign extra resources to investigate and try and improve the flow. Now, that's on the manufacturing line. Toyota's management side decided to apply Kanban in the office as well. So now there's not workstations above everybody's cubicle. That's not how it was implemented. Instead, there was a whiteboard put on the wall, and the whiteboard was divided into columns. And the columns, actually, I think they used a cork board when they first did it. Now we use whiteboards, but I think originally it was a cork board, divided into columns, and the columns indicated workflow cues. So here's a visualization of that. You know, the first column is things that aren't started yet. We can call it the backlog of things that haven't been started yet. Then here we have a design, build, and test flow, but it could be different flow models based on the type of work that you're doing. So there's a design in progress column. So when the designers want to do some work, they grab something from the backlog column, move it into the design in progress column. They used to use index cards with little push pins, and they could move them on the cork board from column to column. Now this is commonly done with Post-it notes, and we take them from one column and stick them in the next column. So it comes from the not started column, that backlog column, and moves into the in progress column. Now, just by looking at the board, as a manager, I can see that design is in progress on that item. Just by glancing at the board, people usually put their initials on it, on the Post-it note, so we know who's working on it. That's great. When design is complete, we move the Post-it note into the design complete column. So now we know the designers completed that piece of work. The designer's got nothing to work on. So we can go say to the designer, hey, go take another one from the backlog, keep working. So we can see who's got stuff in progress, who's idle and has nothing to do, whose work has been completed, and we can watch how fast something flows across the various columns to get a sense of the pace of delivery. Now, when something shows up in the design complete column, that's a signal to the builders that there's something that they could be building. They take it from the design complete, which is their input queue, and they move it into the build in progress column and put their initials on it. Now we know it's being worked on actively. When build is complete, they move it into the build complete column, which is the input queue for the testers. The testers see something there, they grab it, they put it into the test in progress column, and when the testing is done and everything's working and complete, it goes into the complete column, which is essentially our done column. So the first one, the backlog, is like the not started column, and test complete is like the done column. So this is a bit of a process flow model to help us understand the flow of work, the bottlenecks, who's involved in which step in the process. So these cards, these Kanban cards, originally they were index cards. As I said, now they're often Post-it notes. Here's a visualization of one. It's not the only way to do it. This is just one example of what a Kanban card could look like. We have the task area where we describe what it is that this card represents, what piece of work does this represent, our estimated work effort, how many hours we think this is going to take. We number it so we can refer to them by number later for traceability and things like that. We can have the priority of this item so we know things that are urgent, we can move them through. Sometimes the cards are a different color. Something that's high priority is red. Something that's standard priority is yellow, something, or something that's low priority is green, maybe. There's different, sometimes we use different colors instead of a number of stars. Who it's assigned to, that's where you put your initials. And we have the progress bar, which shows how we're doing, how close to being done is it. That's another way, especially something that takes some time. At the end of every day, somebody can go and update the progress bar by just shading in a larger area. So anybody looking at it can get a sense of how it's doing. That's another way of updating it. Sometimes instead of estimated, we have estimated work effort, and instead of progress, we just put work effort remaining. So if we said our estimated work effort was 30 hours of work, the work remaining, progress could be work remaining. And when we haven't started, it says 30 hours. After the first day, it might say 24 hours. The next day, 20 hours. The next day, it could go down to 12 hours and so on. So somebody would just replace the hours remaining on that bottom row and change it to how many proper hours are left on the Kanban card. That's another way that it's commonly implemented, is us estimating or updating the number of hours remaining. So there's an example of a Kanban card. There's many different formats, different fields that people put on it. This is just one common representation. So things you could put on, aside from the main task or activity, who's responsible, whether it's complete, its complexity, any special milestones or dates, maybe who's the key stakeholders you have to deal with, and other things that you might put on it, estimating assumptions, dependencies. There's other things that you might put on there as well. Now, to add some complexity to this model, another thing that we could do is add what's called work in progress limits. Based on our staffing levels, how many things can people work on at the same time? Now, normally, we don't work on many different things and have them all running in parallel for each person. So as an individual, I'm not juggling 5 different things. Working in a Kanban model, I work on one thing at a time and just get it done. This is called clustering or swarming or focus work. So if I focus on one thing at a time, I can pop things out a little bit quicker. Here's a quick example of this. There was a study done a few years ago. They took 8-hour activities that took exactly 8 hours to work, and people were only allowed to work 8 hours in a day. And they gave them, obviously, if you did these in order of priority, you would get one done Monday, one Tuesday, one Wednesday, one Thursday, one Friday, and it'd take the week to get all 5 done. But instead, they forced people to work on each of the 5 items every day. So they were working on 5 items kind of in parallel, juggling the 5 items all at once. And they said, how long would it take you to do it? And they actually measured it. And the actual completion was Wednesday afternoon, the 2nd week, which was on average about a 60% cost and schedule overrun to get this project done because of excessive multitasking. So this focusing, this clustering approach makes a lot of sense. It really helps in getting things done efficiently. You just have to wait for your item to get done. So what we've done is we said maybe we had 3 designers and 5 builders and 4 testers. So each one only works on one thing at a time. So my design in progress column can never have more than 3 items at a time in it. My build can never have more than 5 items at a time, and my test shouldn't have more than 4 items at a time. So now that we've installed our work in progress limits, we know how many things can move into a column. If I have 5 builders, but I only see 4 post-it notes in the in progress column, I know one of those builders is idle, right? That's something I can do just by looking at the board and figure out that there's a problem. From a distance, I can look at it. So sometimes it's trial and error. There's no hard and fast rule because sometimes people can juggle a couple things. Maybe, for example, if I'm often we could allow 2 things per person if there's possible delay. So say I'm working on item 1 and I have a dependency on an outside party providing me information, and I'm stuck waiting for them to provide that information. I could grab a second item and be working on that in parallel, right? So, if you can't work on number 1, work on number 2 until number 1 becomes unblocked again. So sometimes it makes sense to do a little bit of multitasking. So if I had, 3 designers, maybe I would accept 6 things. Each person has 2 things to work on, the main one and a backup one in case the main one is blocked. Maybe that's fair. But there's some trial and error around this. Figure out what is the right number for your people. You certainly don't want 3, 4, 5, 6, 7, like lots of them, because now we're getting into that problem of cost and schedule overruns due to all the excessive multitasking. But a little bit of multitasking might be allowable. Okay, so maybe start high, start 2 and work down, right? So the idea is you want to make sure that you have a limit, and you can adjust it downwards to find something that's more effective, because you don't want things to be slow and get snagged, get slowed down. So there's some options to work on. Okay, break each item, decompose it into components. Each deliverable, break it down into the tasks or subcomponents that are roughly the same size, so that you're not working on something huge and then you can only have 3 things. One is enormously huge and 2 are tiny. That kind of throws it off. So try and break things down into average size work elements and pull them through the system. In other words, don't force a bunch of stuff into your completed column. If you're the designer, don't design faster than the developers can keep up. So only try to time your design completion to match up with when the developer has finished their last piece build and are ready for another piece of design. So you try and synchronize with the person downstream of you so things get pulled through the system. This avoids a lot of work in progress that can cause waste when there's a design change or a problem. If we design the whole system up front, now the builders are building the whole thing, and then there's a minor design change, all that stuff that the builders have been building is wasted, but all of that design work that was done in advance could be wasted as well, as we have to do a redesign. So if you design just in time, there will be less impact, less waste from a significant, for example, design change. So we call this pulling through the system. So your speed of production is determined from the needs of the person downstream of you. The person who's consuming your deliverables will set the pace at which you need to create them. Adjust your work in progress limits to match, so that we can then be a little bit more proactive and just keep in touch with our work in progress limits and just keep an eye on our completion queue. If it gets too thick, too deep, we can slow down a little bit. This is called the delivery cadence. Mary Poppendieck says, a regular cadence or heartbeat establishes the capability of the team to reliably deliver working software at a dependable velocity or speed or pace. An organization that delivers at a regular cadence has established its process capability and can easily measure its capacity. In addition to that, it can also measure its maturity, and it can measure process improvements, the impact of those. There's lots of benefits from having this regular cadence of delivery. And I've pushed for years on my projects to try and measure what that cadence is and try and improve it over time. So excellent. Now, here's a standard approach to using this, right? If we're doing software development, you might be using user stories. It's an agile software development example. A user story is a statement of feature interaction by a stakeholder, right? So it describes a requirement or a feature and how that feature is used by an end user, describing the context of that feature. So in this case, we have 2 features that have design in progress. One is complete. Your developers have one that they're working on and one that they've completed. Notice testers have nothing in progress but one complete. So this tells us the testers have recently completed their testing. There is something for them to work on, which the builders have completed, but the testers haven't taken it into scope yet. They haven't started working on it. So I might say to those testers, hey, you got nothing in progress, go grab that build complete one and pull it into place. Look at my designers. I got 2 in progress, 1 complete. The designers are blazing through this process, right? They're doing really well. The developers, the builders, have one that they're working on. They have one they could be working on, and honestly, those designers might be done those other 2 features fairly quickly. I might think that I either have too many designers, right, or not enough builders. This doesn't look like it's in balance yet, right? Also, testing complete. You know, again, with nothing in progress, that tells me that, but there's something for them to work on. There may be a little bit of management supervision needed here to keep them focused on pulling the next piece of work in. Defects, what do we do about defects? Right? Defects I often do on a different colored card or post-it note. So if my main post-it notes are maybe yellow, the standard yellow post-it notes, defects I might put on a green post-it note because they're sick. Or if they're high priority defects, I might put them on a red post-it note. Red because it's red alert. This is a really high priority defect. Now, if something's in testing and it has a defect, we will raise a defect post-it note, put it in the backlog, and the team will then treat it like any other piece of work. They'll pull it into the in progress column and work on it. And when it's done, they'll float it into their complete column. And that defect will work its way across the different columns until it gets back to the testers who can test that that defect was successfully resolved. If all the defects related to the story in progress have been resolved, then that story in progress can then move to the complete column. Obviously, if it's a red alert, high priority defect, that should be worked on before a green, not so urgent defect. So the coloring might indicate its priority, but that's another way of dealing with defects. So here's an example, right, of a situation. We have 3 stories in the backlog that haven't been started. My designers have nothing in progress. They have a whole bunch that's complete. Developers are, and we have designers can work on 3 things in parallel, but they've got nothing being worked on right now, but 3 things that are available. That tells me my designers are idle. They should be working on those 3 unstarted user stories, but they're not. I need to go have a talk with the design team and seeing what's delaying them. I need to manage that more closely because I'm wasting capacity. My developers can work on 5 things at once. Unfortunately, 4 of them are defects, with only 1 of them being a new feature. So this tells me that instead of working on those 4 design complete user stories, I've had to consume myself with 5 defect corrections and 1 user story, or 4 defect corrections and 1 user story. So this tells me I got a significant quality problem that's interrupting my pace for the developers. So I've got idle designers that need to be watched. I got developers doing shoddy work. Their quality is poor. They've got a very high percentage of defects, and that's slowing them down from getting their real work done. Now, the developers have built 1 item. It's sitting there idle, waiting for the testers, but the testers are busy with testing 2 new features, but they're also stuck testing 2 defects. So this defect problem is working its way through the system. Poor quality has slowed down the testers with double checking the defects were corrected, and it's also slowing down the developers because they're having to refix their code and not work on those new features. So I know for sure I've got a quality problem, and I've got idle designers who aren't working as hard as maybe they should. Okay, next. What's going on in this one? I have a whole bunch of user stories that haven't been started. 1 with design in progress. I could work on up to 3, but I've only got 1. So 2 designers, or my designer capacity, is not being used effectively. So this tells me right away, I got to do something about that. Now, there's nothing design complete because my designers aren't working fast enough. So there was nothing for the builders to work on. They're idle, but it's not their fault. There's nothing for them to work on. There's no design ready. Now, my build is complete. There's 3 user stories that are done. They're just sitting there waiting for the testers, but my testers are swamped. They've already got 4 things to work on. They are working on 3 more things that are ahead of them, ready for them to work on. The testers are swamped. So what's happening here? Maybe a resource imbalance. Maybe I need more testers. Maybe I need more designers, or maybe I can slow down the number of builders, have fewer builders, would have put this in better balance, because the builders have built everything that was handed to them so quickly. Build, done. Now they're just sitting around twiddling their thumbs, waiting for the designers to give them something else to do. They're idle. They're just underutilized at the moment. Testers are swamped. So either add more testers, or if I reduced the number of builders, maybe the system would be in a little bit better balance. Or maybe I need to, and also maybe I need to add another designer or something, because the design is happening too slowly. Already I'm not using the full capacity of my design team of 3 items. I'm only working on 1. So there's a couple items that could be fixed there. What about this situation? Somewhat similar, but things have changed. So now my designers are, there's 3 items they're supposed to be working on. Two are in progress. One just got finished, so now the designers are busy again. My builders quickly just finished 5 items. They could be working on 1 more. We're still not quite in balance here. We're still not balanced because my designers can't keep up with the needs of the builders. My testers, we got rid of the quality issue we were facing, but my testers here could work on 4 things. It looks like there's 2 in progress, 2 they just finished, so they could pull in 2 more from what the builders have just completed. So this is looking a little bit better, but again, we still have an issue. We probably still have too many builders. We have a resource imbalance. So these bottlenecks we can spot through looking at the flow of work through the Kanban visualization. This helps us identify and potentially now focus and remediate blockages by knowing exactly where they are and what might be causing them. We can address these defects immediately by giving them a different color. We can, where possible, it helps to automate testing, especially regression testing if you can. That speeds things up so testing can keep up and won't be a bottleneck in your process. Sometimes if we do something where we pair up individuals to work together side by side, that gives new perspectives on work. 2 heads are better than 1. We might be able to spot issues faster. People can keep each other more motivated and focused, right? And it helps improve quality. They can inspect each other's work as they go. That's a technique that can certainly help with bottlenecks. And lastly, reassigning idle staff to help fix blocked queue items can be very helpful as well. In this case, we have too many builders. So maybe one of the builders, one of the more senior builders, might be able to help with some of the design work. So they can be reassigned to the design team to speed up the flow of work from design to build. That's what we're talking about when we talk about temporary reassignments. So these are some techniques that can be used to spot bottlenecks in a project management context. And lastly, even though there may be different colors for defects, we can provide special rows called fire lanes or priority lanes for emergency stuff. So there may be certain features or user stories that are exceptionally high priority. We can put them in that fire lane, and that tells people when you're about to grab another piece of work, grab the one in the fire lane first to help move it along as fast as we can across the columns. That should be everybody's immediate priority. If there's one in the fire lane that you can work on it and move it into the next column as fast as you can. So that's another way of dealing with it, right? So we can cap the number of items that go into a fire lane. Not everything's urgent. It should be really for true emergencies, right? Don't let everything become a high priority urgent item. That's not the intent, right? So let people focus on what is key. Now, here's another case for fast tracking. Here's another example where we have a fire lane and a high priority lane. Fire is dire emergency, and then high priority is things that should be worked on before the main ones. That's another example. So here, in this case, high priority is something that's just very important. So when you're grabbing your next item, grab that one first. But fire lane should be drop what you're working on and grab that one that's in the fire lane and move it across as fast as we can. So we have the ability to drop everything and work on the fire lane first, and we have the ability to, when you do finish what you're doing, grab something high priority from the priority lane and work on that. That's another way of dealing with this. Now, in this example, we see something different. We have changed columns. In the prior example, we had a design, a build, a test. It's almost like a little mini waterfall workflow. But in this new one, we have 2 parallel streams of work. This is called agile fast tracking, where we're building and testing the deliverables for this work stream in the bottom Kanban, and in the top Kanban, at the same time, the designers are gathering requirements and doing design of next iteration's work so that the design will be ready for the builder's next iteration, right? So we're doing the requirements to design one iteration in advance of the build and test. That's another agile technique reflected here. So really what you got to do is think about the big picture, right? Is it going to help to have additional lanes? Is that going to help you get the flow of work moving faster Is it necessary? I've seen people go overboard and do way too many. If you're working on multiple projects, though, if your team is juggling multiple projects, it might not hurt to have additional lanes for your different projects. So one lane could be project A, another project B, another project C, and you can juggle how much of which items you're working on for each of the projects. So maybe this week project A is urgent, so I'm going to work on 3 things for project A, and there's just one element from project B that I'm going to work on because I have to show that I'm continuing progress on that one. And maybe this week I'm not going to work on project C at all because it's not as urgent as those other 2 items. Maybe that's okay. Next week it might be mostly project C. So the idea is that these lanes help us organize all the work that our team is being asked to do, especially in a shared services organization when I may have multiple projects on the go. So think about what your goal is for your Kanban, and what the goal is will drive its structure as well. Okay, let's look about some other lean workflow techniques, right? Other than Kanban. Kanban's just visualizing. Some of these other ones will allow us to actually change the work that we do in a significant way. So line balancing, right? Figure out the average time it takes for each step in your production process. We call this takt time, right? Takt time is how much time that it takes to get an item through our production process at all the various steps. So measure this average time and make sure that your production doesn't move any faster than the slow one. This creates a true pull model and prevents you from having piling up works in progress. That minimizes inventory waste and things like that. Right? This also helps us figure out what are the bottlenecks. The steps that have the slowest measurements for their production time for that step are the ones that are bottlenecks and that may benefit from automation or more resources, etc. Another technique is to create maps of our workflows to figure out all the handoffs and steps in the process. Sometimes there's surprises in how many production steps we have. Some people aren't aware of how complex their production model is with all the reviews and sign-offs and approvals. So you can create swim lane or love 'em diagrams, right? Line of vision models that help you figure out the flow of work. So those diagrams will help look at all the various steps and approvals, and use that as a basis for our continuous improvement discussions, our Kaizen discussions. You can look at those workflow diagrams and determine what steps are candidates for improvement. Are there sign-offs that can be combined? Are there steps that aren't necessary anymore because of improvements in quality or reliability in other production areas? Right? So look at those process maps as a way of improving your overall throughput. Another lean technique that we can use in the project management context is looking at the process for building something and changing the design to make it easier to build. So there's an example. If somebody is creating an overly complex design for a product, that make it very, very difficult for the manufacturing team to create it. Maybe some kind of computerized widget that the engineers have designed is no longer easy to manufacture because the tolerances are too tight, or maybe the way it was designed makes it too hard for the tools that the manufacturing people have available to build it. So the idea is to refine the design to make it easier to build. We call this design for ease of manufacturing, DFEM, or sometimes it's called DFMA, design for ease of manufacturing and assembly. So the idea is it's figure out first how it's going to be built, and then do your design to meet the capabilities of your build process. In software development, this is called test-driven design. It helps us avoid building or designing in too many features, making something too fancy, more than what the business really needs. So using this technique reduces the amount of time to produce something because you're not building extra. It reduces the administrative times for reviews and approvals. It reduces our support costs because it's simpler to support because it's a simpler solution. So that's another one. How about design for ease of use? So sometimes we create what we think is best practice, but it's not practical. It may sound that way on paper, but when you look at real use, it's going to slow people down. Things are just wasn't thought through from a practical perspective. So many processes have too many built-in reviews and approvals because something went wrong once in the past. We've added a new step to our process. Makes sense to prevent that problem from ever happening again. But now you've burdened all future activities going through that process to have to do that extra step. You've slowed it down. One has to take a look at what's realistic, what's reasonable, what's usable, and maybe the process is getting too complex to be usable again. Maybe we have to do a risk assessment. How likely is it that that problem in the past will reoccur? If it's once in a blue moon, then maybe we can remove those steps from the standard process. Maybe not every project needs to go through those steps. Maybe there's some other determination that can be made earlier on to figure out if that step is relevant or not. So design for ease of use fixes those underlying issues to remove these extra steps that aren't necessarily helping in every case. Okay, so that's another technique that we can use. And one of the last ones I want to talk about here in this category is this concept of one-piece flow. Again, this is that pull model, not a batch model. If I do things in batches, I get 30 things I need to do my process step on, and I do the whole batch of 30, then I put them into my work complete pile that's waiting for the person downstream of me to use them. If there's a change in design or specification, now I have 30 things I have to throw out because I rushed through them all and now they're garbage. Whereas if I'd worked on things one at a time and waited for the person downstream of me to pull them from me, I would not produce another one till my pile is empty. So if I have a pile of one item that's done, waiting for the next person, as soon as that next person grabs that one to do their step on it, I produce another one and put it in the pile. Then if there's a change in design, there's only ever one I have to throw out, not 30 of them, right? So this batching can be very, very wasteful in the face of change, in the face of high change. This is sometimes counterintuitive because normally when we do things in batches, there are efficiencies to be gained there, but they're in process efficiencies, but there might be now increased waste if there are changes. So we have to balance that waste versus the stability, and which seems more likely, which seems to be more more risky to my project, so we can take the appropriate actions. Here's another example for software development. Imagine you've written tons and tons of code, awaiting testing. Instead of building a piece of code, testing it, getting feedback to change your code and learn what practices are working, let's just write tons and tons and tons of code that hasn't been tested yet, nothing's working, and then we finally get around to testing it and realize the design is wrong. Now all that coding needs to be thrown out. Wouldn't it be better to build a piece of code and test it to see if it works, the design is stable, before you write the next piece of code? So that's what we're talking about, is this introduction of waste and rework as a way of slowing down overall efficiency, but we still have to look at our process flow as well. Batching increases flow, but introduces the risk of dramatic waste and rework. It could actually kill the flow for a while if there's a change, right? It's huge, massive disruption. So that may be too much risk to take on. Okay, I'll take some questions now. If there are any questions, the best way to reach me, by the way, is Kevin at okay, I'll take some questions now. While we're waiting for you to enter your questions into the chat window, best way to reach me is via email, Aguanno, A-G-U-A-N-N-O, Aguanno at procept.com, P-R-O-C-E-P-T.com, Aguanno@procept.com. I'm very open to questions. I will always answer them. It may take me a little while to get to you if I get lots coming in or I'm on vacation while you send it in, but I will eventually respond to all queries. Aguanno@procept.com. Okay, waiting for the questions. Again, you can just type them in the chat window. If you have any questions, that would be great. First question, Michael. Michael asks, Is it possible to get a recording of the first session? Yeah, of course. This video recording and the first one are both being published to Procept's YouTube channel. So you can go to YouTube and look up Procept, P-R-O-C-E-P-T, look up Procept, look up our YouTube channel, and you'll find both the first and the second one. It's Lean PM Part 1 and Lean PM Part 2 is this session. You'll be able to get the recordings. Excellent. Okay. Okay, Shamira, I don't understand your question. You're going to have to reword it, please. I'm sorry, I don't get that. I don't understand the question. Okay, next question, Mo. Oh, Mohammed, sorry. Okay, no, I could call you Mo. Okay, thank you. Okay, so Mo asks about these lean practices. He says, if I do all of these things, am I lean? Well, lean is a philosophy. It has like 12, 13 philosophical principles and a number of practices. We've only extracted a few of them here. In this first and this second webinar in this little series on lean project management, we've only extracted a small subset of lean practices that are related to project work. Remember what a difference is between a project and operations. A project is something that has a defined start and end. It's usually a short-term item. You pull a team together, probably unique to this project, right, or temporarily assigned to this project. We get the project done, and then the team scatters and goes back to their regular work, maybe another project or their regular operations work. Operations has a consistent team that does the same piece of work over and over and over ad infinitum, forever and ever. They do the same piece of work. Maybe we're a production line or an assembly line and we just do the same activity over and over. That would be an example of operations. So lean is an operations management practice, philosophy, principle primarily. That's where it was started. So a lot of the lean practices really are intended for example, manufacturing companies that have assembly lines. That's where lean got its roots, got its start. So that's where most of the lean practices come from. Not all of them are applicable in a project context, in a project management context, where it's a one-off. We're going to do this project once and then we leave, and our next project may look quite different with different team members and different scope. So this is a subset of lean, not all of it, and you may find this helpful for helping with the throughput on some of your projects. But again, every project's a little bit different. We haven't included all of the practices, and you may find other ones that are more applicable or more useful for you as we move on. Okay, any more questions? Kamika, I think I might know you. I only know one Kamika. Yes. Okay, it is the Kamika I know. Thank you. It's good to see you again. Okay, Kamika asked, do I get PDUs for this session? PDUs, professional development credits? Yes, you do. So anybody who is a PMI certified project manager, whether you're CAPM or PMP or one of their other agile certifications, if you have their PMI ACP or digital or disciplined agile scrum master, or even your PMI risk management professional, etc., you can claim PDUs for this session and the past session as well. Where you get this recording, there may be a PDU code provided to you that you can claim on the PMI website, or if you attended this live session, at the end you will be emailed a certificate, a completion certificate, because we can verify your attendance with a PDU claim code that you can use with PMI. Professionals from other designations can also claim credit for this. If you are a member of, you're a certified software quality engineer from the American Society for Quality, you can get recertification credits for this. If you are a DAMA certified data architect, you should be able to claim recertification credits for this. If you are a KIPS IT professional, you can claim recertification units for this. If you are a Scrum Alliance Scrum Master, you can claim Scrum Education Units, SEUs, for attending this session. So this course is eligible for many different recertification credits. If you have any questions, just send me an email. Okay, we're out of time. I'd like to thank everybody for attending. Name's Kevin Aguanno, Aguanno at procept.com. Feel free to reach out, connect to me on LinkedIn. Love to hear from you. Talk to you later. Bye for now.